7 variation. My name is Jorge and this is for college algebra. So here we're going to be talking about, we have 3 objectives. The first thing we're going to talk about is direct variation, inverse variation, and we're also going to talk about joint variation or combined variation. So the first thing is, let's talk about direct variation. So let x and y denote 2 quantities. Then y varies directly with x, or y is directly proportional to x, if there's a non-zero number k such that y equals k times x. Now, number k is what we call the constant of proportionality. Now, excuse me, the equation is y equals k times x. K is greater than 0 and x is greater than or equal to 0. And there's the graph of this particular equation. So the first example is going to talk about some monthly mortgage payments. So the monthly payment P on the mortgage varies directly with the amount borrowed B. If the monthly payment on the 30-year mortgage is $5.95 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed B for the mortgage with these terms. And then we're going to go ahead and find the monthly payment P when the amount borrowed B is $125,000. So the first thing is that we know that P varies directly with B. So P equals KB for some constant K. So what we're going to do is we're going to solve for K. We know what P is, which is 5.95. We know what capital B is, and that's 1,000. So that's going to allow us to solve for K. Now, solving for K, we get that K is equal to 0.00595. So using the formula P equals K times B, we're able to then solve the second part, which is find the monthly payment for $125,000 borrowed, and the monthly payment is $743.75. The next thing we're going to talk about is inverse variation. So let x and y denote 2 quantities, then y varies inversely with x, or y is inversely proportional to x, if there's a non-zero k, constant k, such that y is equal to k over x, k is greater than 0, and so is x. So here's an example. The max weight W that can be safely supported by a 2x4 inch piece of pine varies inversely with its length. Now, experiments indicate that the max weight that a 10-foot long 2x4 piece of pine can support is 500 pounds. So we're going to go ahead and write a general formula that relates the max weight in pounds to length. Then we're going to find the max weight that can be safely supported by the length of a pine that's 25 feet long. So the formula is W equals K times L. Now, so we know what W is and we know what L is, so we're going to go ahead and solve for K. And so K equals 5,000. Now that we know that K equals 5,000, we'll use the formula W equals K over L to solve the second part. So a 25-foot long piece of 2x4 pine can safely hold 200 pounds. And here's the graph for that particular equation. So the next thing we're going to talk about, and there's not a straightforward example for this one, but it talks about the loss of heat through a wall that varies jointly with the area of the wall and the difference between the inside and outside temperatures, and then varies inversely with the thickness of the wall. And the equation for this particular example is L is equal to K times AT over D. Now, L is the heat loss, A is the area of the wall, T is the temperature, and then D is the thickness of the wall. And we'll talk about this in class. So the next thing I want to talk about is another joint variation. So the force F of the wind on a flat surface that's positioned at a right angle to the direction of the wind varies jointly with the area A of the surface and the square of the speed V of the wind. So a wind of 30 miles per hour blowing on a window that measures 4 by 5 has a force of 150 pounds. So what is the force on a window that measures 2 by 3 that's caused by a wind of 70 miles per hour? So the first thing is that the formula is F is equal to K times A times V squared. And we have all these values other than K. So the way we got A is 4 times 5 is 20. So we solve this particular equation for K, and K equals to 1 over 120. Now, using this information, we're able to solve the second part of this. So we know what K is, we know what A is, we know what V is, so it's 245 pounds. So the force on a window that measures 2 by 3 by a wind of 70 miles per hour is 245 pounds. And that's the end of lecture 7 for the first part. Thank you.